Suppose you deploy a Chinese dependency parser on medical records, patents, or customer service text. The parser already includes a tokenizer, but its word boundaries may disagree with your domain or your target treebank. When they disagree, parsing accuracy can drop sharply while the pipeline still returns well-formed trees, so the damage stays silent. Lightparseadapter turns this hidden compatibility problem into an inspectable routing decision. The novelty is the routing layer itself. Instead of building yet another parser or tokenizer, it decides, with evidence, which existing interface is safe, with no retraining. For tabs mirror the architecture, probe your text, Routing Explorer, Evidence, and Report and Deploy. The Routing Explorer is risk control before deployment. On HK, adaptation improves span loss from 0.3080 to 0.4089, so the router accepts the adapted path. On GSD Simp, blind adaptation would drop span loss from 0.7464 to 0.6460, so the router keeps the native input. Drag the threshold slider and watch a wrong threshold route into a loss. The system shows this risk instead of hiding it. The highlight is your own corpus. In Probe Your Text, an engineer pastes real product sentences, selects the learned logreg adapter, and runs the corpus compatibility check. The system profiles boundary drift and overlap, matches your corpus against cached treebank evidence, flags the lowest overlap sentences for review, and returns an explicit route recommendation as a downloadable report. No parser runs on your text, and nothing is stored. The Evidence tab keeps the claim honest. It includes negative diagnostics where fixed pre-tokenization hurts HONLP and TranKit, which is exactly why a routing layer is necessary. For pipeline integration, Report and Deploy ships the same logic as a 3-line API. Create a token routing engine, call probe on your text, and get the route, drift, and boundary overlap. Lightparseadapter saves teams costly retraining when the native path is already safe, and warns them before a risky switch, an evidence-based compatibility layer that tells you when adaptation helps, when it is risky, and why.